Magandang araw mga mag-aaral. Ako ang inyong guro, Daryl J. Mendros Balbin. In this video, I will use method of members to solve a sample problem. The breaking strength of the cable FG that supports the portable camping stool is 400 pounds. Determine the maximum weight W that can be supported. Neglect friction and the weights of the members. We will solve this problem using method of members. In method of members, we analyze the free body diagram of each member of the frame separately. The members of the frame are usually 3/4 members. A 3/4 member, or a non-axial member, is subjected to 3 or more forces applied at different locations. In method of joints and method of sections, the members we analyzed are axial members, meaning they are only subjected to axial tension or compression. A 3/4 member or non-axial member is not only subjected to axial tension or compression, but also subjected to bending. Let's first consider the free body diagram of the whole frame, wherein we have a normal reaction at A, let's call that NA, and another normal reaction at E, NA. I'm only going to solve for NA. You will understand the reason later. To solve for NA, we simply take summation moment at point E, and that is equal to 0. Summation moment at point E is equal to 0. For NA, it tends to rotate clockwise about point E with a moment arm of 18. So that is positive NA times 18. For the weight W, it tends to rotate counterclockwise about point E. And its moment arm from point E is this distance, which is equal to 18 inches minus 6 inches, which is equal to 12 inches. Therefore, this is negative W times 12. And this is equal to 0. Expressing now NA in terms of W, NA is equal to 2/3 W. This will be our equation 1. We now consider the free body diagram of member DC. The reaction at the pin connection at D has two components, horizontal component dx and vertical component dy. The directions are assumed. At point C, we have a normal reaction NC. Now I'm going to solve for NC. Again, you will understand the reason later. To solve for NC, we simply take summation moment at point D equal to 0. So summation moment at point D is equal to 0. NC tends to rotate counterclockwise about point D with a moment arm of 18 inches. So that is negative NC times 18. For the weight W, it tends to rotate clockwise about point D with a moment arm of 6 inches. So that is positive W times 6. This is equal to 0. Expressing now NC in terms of W, NC is equal to 1/3 W. This will be our equation 2. Do you notice something? So we expressed NA and NC in terms of W. Lastly, we consider the free body diagram of member A, B, C. At point A, we have a normal reaction NA, which is from equation 1 equal to 2/3 W. At point C, we also have a normal reaction NC. You will notice that its direction here is downward. Why? Because by law of action and reaction, if at member DC, NC acts upward, in member ABC, NC acts downward. Law of action and reaction. And from equation 2, NC is equal to 1/3 W. Now this is the reason I'm talking about. The reason we expressed or solved for NA and NC in terms of W. We also have a cable FG, which has a breaking strength of 400 pounds. Now you have to remember that cables, wires, and ropes can only support tensile force. Therefore, the force in FG is a tensile force equal to 400 pounds. And for the reaction of the pin connection at point B, it has two components, horizontal component BX, vertical component BY. Again, these directions are assumed. Now, how do we solve for the weight W, which is asked in the problem? We simply take summation moment at point B equal to 0. That way, NA and NC, which are both expressed in W, have moments about point B, as well as the tensile force, 400 pounds. So we have summation moment at point B is equal to 0. For NA, it tends to rotate clockwise about point B with a moment arm of 9 inches. So that is positive NA in terms of W, 2/3 W times 9. For NC, it also tends to rotate clockwise about point B with a moment arm of 9 inches. So that is positive NC, which is, in terms of W, 1/3 W times 9. And lastly, the tensile force tends to rotate counterclockwise about point B with a moment arm of 4 inches. So that is negative P, or 400 pounds, times 4. And this is equal to 0. Notice now that because we expressed NA and NC in terms of W, in this equation, we only have one unknown value, which is W. So we can now solve for W. W is equal to 177.78 pounds.